What's up, nerds? Harbinger here. Been a while since a video, but haven't really needed one. Also kind of awkward because I'm not in a soundproof closet, so everybody out in the hallway is listening to this sweet flipped video right now. I assumed you got tired of looking at a blank North Syracuse screen, so here's my handsome face. It's like the one and only time you'll probably see me in a tie. So, what are you gonna do? Today's daily meme is making fun of me. Hey, me on YouTube, you haven't heard that since like I threw your dad in a volcano and cut off his legs. There was a lot of really funny Star Wars memes, but this is actually more appropriate and school okay than some of the other funny ones that I saw. But trust me, this may come as a surprise to people, but there are some inappropriate, occasionally funny things on the internet. This is me showing discretion. Alright, so today we're going to be talking about functions. And I'm not going to be language specific. Functions are all over programming. My VB students probably know them as subroutines, and I'm going to show kind of like a subroutine today, but in a different language. Java has them, we call them methods, and C++ and C, they call them functions, and there are some subtle differences between some of them, but at the same time, they all kind of do the same thing. And if you remember functions in math, let me jump to Notepad for a second. A function in math is like, I'm not going to give the precise, perfect definition, so if you're following along at home and you're like, wait, he has a degree in math, he should know this. I know it, but I want to make sure that it's done in an understandable way, so I'm not trying to be technically perfect right here. Takes in some input, so not necessarily one input. There are like f of x comma y, but I'm not talking about that right now. I'm just talking about like, hey, you take something in, maybe in this case. Sometimes you take in nothing and you just deal with whatever you're told to deal with. But it takes in some input, maybe returns at most one output. All right. So maybe you return something, maybe you don't. Like, you don't have to give back information, but that's what a return statement does. So input we're going to see in a second. It's stuff coming in. So what's coming into the function? And that's like in an f of x problem, that's the x. That's the stuff that you have to process in some way. And then the return statement, you're going to hear me say return a lot. Return statement is like the information that's getting passed back. So the information that's... Alright. So that's not awful. It's useful. And why use functions? Well, it really makes there's an H in there. It makes your program more readable, right? If I can look at it in like discrete, compartmentalized chunks, it might be easier to understand than a really long set of lines of code that all kind of go together. And also, if you can compartmentalize chunks of code, maybe you can reuse them in other programs. If you had a program that checks if a number is prime or not, which we do often in computer science, but I'm not doing it right now, if all it does is takes in a number and returns if it's prime or not, like if it's true or false, that's cool for the program you're writing, but you might need it in another program too. So it's useful to kind of define a function instead of just copying some code over that somehow is in the middle of your program and paste it somewhere else. And oh wait, I got these variables I've got to port in also. A function's like a standalone thing, and it's designed to make your code more streamlined and, like I said, compartmentalized and more readable. That's cool too. So there's definitely like a readability. I don't even know if I spelled that right. That letter right there could be an I, but whatever. You know what I mean? So, readability of code. It makes it more understandable in like a discrete set of code statements way. So let's see. Makes code more abstract, I guess. Like, there's this abstraction process in which you take an idea and you take it out of the context of the problem you're dealing with, and you're like, oh, if anything ever needed this, it could rely on this code and my code should work. So that's kind of cool. Makes code more abstract / I keep saying compartmentalized, Mentalized, meaning that like you can take a little chunk and you can use it unto itself in other ways and capacities too. So like I gave the example of a prime number thing. That's pretty cool. And good for now. Right, I'm going to show you some examples, and we're going to talk about some common errors. And I'm probably going to make some common errors just so you can see where they might go wrong. Understand, please, there are a lot of ways to write functions, and I'm not going to show all of them. Scratch does functions too. It's not a big fan of the return statement. There's some workarounds that I'm not going to deal with. I would show Java, but it's got a lot of parts that might freak some people out. So instead, I chose to go back to our good friend Python. So I'm going to increase the font size here so you can read a little bit better. I start off with a function call to greet them. Right? I want to say hello to you guys. So here goes. Greet them says, I'm going to define a function. Note the purple word def. So in Python, def says, hey, I'm defining a function. Here's what it is. And if you're ever asked to greet them, note the parentheses, just like an f of x kind of thing, do this. So if I call just greet them, it says, hello, I hope you are all well. I hope you are well, not all of you, just you in particular. So if I ever call greet them, it's going to go up here and do this. And if I put it in like a loop where I can, greet them and greet them and greet them, it's going to constantly jump up here, execute this code, and then jump back down. So a function is kind of like a way to jump to a different part of the program and then jump back and pick up where you left off. That's kind of cool. Note there's no input, right? It's not like an f of x thing. It's just like an f, oh, there's no inputs. I didn't say greet them 3 times or something, or greet them true, in which would be capital, or something like that. This is just a basic function. So, for now, hello, I hope you are all well. The next function I wrote is involving number, please. But for now, it just says, hello, I hope you are well. That's cool. So let's go to the next part. It says ask equals. So basically, I'm going to take in a number, and you saw that a second ago, and I'm going to input it. In fact, input itself is a function. It just kind of gets overlooked. It's one of those first functions you learn without knowing what a function is, but I'm going to blow it off for now because it's not really that important. Kind of like an int cast. But whatever. Hey, can you give me a number, please? And then do something with it. So I'm going to print you the result if it is even or not, which means I've typed in a number and it stored it in ask in the memory. It's going to use that number and it's going to pass it to the function is it even. Is it even is all the way up here. Here's some future functions coming your way in a second. So ask, I'm going to type in a number down below like 71 or 36 or 117,000, whatever. And here's the input. It doesn't have to match the name, right? Down here it would call ask, right there. And I put in ask as an input. And this is just like a generic thing. Hey, any input coming in, well, if it's even, return true. Otherwise, return false. So this actually works really well. I hate the capital T and the capital F for true and false. But I keep messing up on that one. I actually remembered this time, which is kind of funny. There are other ways to do this, and you actually see a different way of returning a truth value down here. But we're going to talk about that one in a second. But the return basically says, I promise to give back some information, and here I'm giving back whether the number is even or not. Right? So I can store it down here if I really wanted. Here I just print it out. So if I want to run it, it would say number please, and like 54. It says true. And like, hey, 54 is even. Actually did a pretty bad job formatting the input, because it's right up against the word please. But I can fix that, right? Like, if you didn't know, that's a return character. Like, it jumps down a line, but whatever. That'll just give me more space so it looks nicer. I'll show you what I'm talking about. So, 55, false. See how 55 is on a different line this time? So that works. Cool. What I could do if I really wanted, I could say something instead, like even or not. I can make a new variable, and I can set it to is it even of ask, and then I could just print the truth value of even or not. Even or not. So this does the same thing. Hey, go evaluate this truth value. Is it even using the input? store it here, and then print the value of what's stored. So it should work the same. 114, true. That's cool. So I like that there are multiple ways of getting information and storing it and then using it. So I tend to like this when I'm writing code, although more efficient people tend to do something like this. Hey, here's a function, and we're going to print the result right now. But what if I want the result to be used over and over and over? I'd probably want to store it in a variable like this. To be honest, a common mistake, I'm going to comment that out right there. So a common mistake is to say, is it even? Ask. This is on the practice test, I think, for the AP test, because you put in a number, it correctly takes in that number and goes to is it even, and it does its thing. It's like, hey, is it even? Here's a number, like 114, and 114 mod 2 is 0. All right, return true. And it jumps out here, and it doesn't store it anywhere, and it doesn't print it. So people are used to this return statement, and they forget to store it, and it's almost like you ask something for help, and it says the answer back, but you're not listening. You know, like you're not recording the data, you're not doing something with it. So now if I were to run it, number please, 75. Word please. So that's a big goof up, and I'm pretty sure it's one of the practice problems too. Like if you don't store it somewhere and then use what's stored, the program isn't going to crash because it doesn't know it did something wrong. It's like, all right, I did is it even, and everything worked, and what's next? You didn't say, hey, store it here and then print that value. You didn't say, hey, just print the result of this. Like I could put a print right here and that'd be okay, or I could put a variable declaration. So a lot of people goof that up. So we just have to be super careful about what's happening in there. So here, ask equals input word please, and it's going to print the backwards value, we hope, right? I can name the function whenever I want. Maybe I called it backwards and really it just capitalizes things or something like that. That'd be funny. But usually functions, you kind of want to name them something that makes sense. And if you guys write functions, I'm sure you're going to call it something like something that makes sense. I see that one like 1,000 times and it stopped being funny. But anyway, I don't expect you to know all of the loop mechanics, but really fast from my Python people, here's what's happening. I've got a function that I defined called backwards, and it's going to take in an input. This is saying, hey, I could take in something here, and it's expecting a word because I didn't cast it down below as an int. So, hey, you've got this word coming in called WD, word, right? And so I think everybody should understand that, what's happening here. I'm defining a function called backwards, and it's expecting one input. Could I actually make more than one input? Sure can. You know, maybe I put in like a truth value or something like that, like val, who knows what, you know, and maybe that says, do you want it to go backwards or forwards, or I don't care, I didn't write the code like that for now. But when functions, you can actually take in a whole lot of inputs. I made an empty string called string base, which basically, it's got nothing right now, but I'm going to build onto it. I'm going to put letters onto the string so I can build a word up. So I think everybody should understand this top line, what's happening, and I think you should understand what this does. It's a blank, empty string. It has a length of 0, and it's there because I want to tack stuff onto it, which is happening down here. In fact, because I'm awesome like that, define a function named backwards that takes in WD as input. So that's not awful. And I'm going to comment again. And so these are just comments. You know, these are like me leaving you notes here. Empty string, so that we can build on it. So far, so good. And then let's see. This is a loop, and you don't really need to know the loop syntax per se. Just know that it goes backwards. You know, if I have the word like cat, this says start at the very end, work your way to the beginning by going backwards. You don't need to know this though, so you're okay. But hey, tack onto your empty string whatever letter we're on right now. So here, loop backwards through string, and tack on one letter at a time, add a Tim, and then like give back the word when you're done. So return the resulting string. So now when I do it, number please, whatever, 43, word please, cat, tack. It's the backwards version of cat. You know, maybe I want to do like, I don't know, like a longer word. So Harbinger is awesome. Nope. Really? Oh, because it says number please. So can't be good all the time. 44 Harbinger rules. So lure Regnabra. False. So what this is doing here, this false, it's a result of this. I said before you can store the result of a function in a variable, and I did that down here just to show you that it can be done a couple different ways. Hey, you can print the result of this, or I can just store it and then use it. So these are kind of doing something similar in that they're calling functions and we're doing something with the result. But let's see what isPal does. I think you kind of know already, but whatever. isPal looks up here, and it's saying return WD equals backwards WD, which means it's like a setup like this. I was just being more efficient. It means return the truth value of this. It means if the word is equal to the backwards version of the word, return true. If they're different, return false. So I could have written it instead like if word equals backwards word, return true, else return false. And that's awesome and all. I should probably indent it correctly, but this and this are the same thing. Heck, if I wanted, I could even do something like back WD equals backwards WD, like that. And that way, like that works also. Hey, I'm the backwards version of whatever's coming in, and we're going to see if we're the same. To be honest, this is the most efficient, and I love this. I learned this from Java, and it works in Python too. Hey, return the truth value of if the word is equal. So some people are going to get weirded out because this function is calling this function for help. Hey, I'm a function called isPal, and they called me in the first place, but I'm going to ask you for help, and whenever you get back some information, you're going to give it back to me, and when I'm done, I'm going to give it back to down there. So math-wise, this is actually like an f of g of x problem. You know, this function is going to call this one for help, and whatever the output is going to jump back here and then jump back down. So f of g of x, you have this input x, and it goes into g, and you evaluate g of x, you know, however you need. Whatever the output is from the g function, you give it back to f, and f evaluates that, and then it's got its own kind of result. So that's what's happening here. So that's cool too, and I like that a lot. The funny thing is though, right now, I don't even need this, right? Like, that works too. Hey, if you were the same as the other one, like if you work backwards and forwards, true, return is like a warp zone. It jumps you right out. So if it's a palindrome, true, and it's done. The only way it's getting down here is, so I should probably comment that one out first. The only way it's getting down here is if this didn't work. Right, because otherwise it warped you out, but it didn't warp you out. So it's like, oh, return false, not happening. So you don't always need the else, but it's usually a good idea to have, and people like it in there because it makes it more readable. Right, so I'm going to delete that for now. Well, for good, because I'm not going back to this one. The last thing people should know, which I think is really useful to know, you learned it in Algebra 2, I think. Maybe it's Algebra 1, but whatever. Def. I'm going to do a summation of a number's digits. So like 125 is 1 plus 2 plus 5. And sum, and I'm going to name it like sum num, right? I've got an input called num, and maybe sum is a special word, maybe not. So sum this. Definitely blue, so I know that I'm okay. Now I'm going to just assume that it's a positive integer, or at least a non-negative integer. So I'm going to leave myself a comment up top. Assuming num is non-negative. Yes, I know assuming is dangerous, but I'm the one writing the code here, and I'm the one assigning the problem, so, you know, this is cool, whatever. So what's the easiest possible summation? It would be a single-digit number. So I'm going to say something like, if num is less than 10, I'm going to return num. Sorry, Java. So that works, right? Like, hey, what's the digit sum of 5? It's 5. You know, what's the digit sum of 9? It's 9. In this case, what's the digit sum of negative 3007? You know, negative 3007. That's why I'm just making this kind of precaution here. Otherwise, and again, not necessarily needing the else, but whatever. Otherwise, I'm going to chop it down a little bit. So I'm going to say the ones digit. That's the ones digit of num plus a smaller version. So this is actually doing a whole lot here. I should probably have the word return, because otherwise I would violate what I told you guys earlier in terms of, hey, people forget to return, or they forget to store it, or whatever. So what's going on here? This is defining a function called sumThis, and I've got an input coming in called num. And if it's a single digit number, well, that's just the sum, right? Like, what's the digit sum of 3? It's 3. But what's the digit sum of 372? Well, it's the ones digit, 2, plus the digit sum of 37. Remember, slash, slash, I think, if I remember this one right, divides and chops off the decimal. I could be wrong, and, you know, we could watch this crash and burn in a second. So, said again, what's the digit sum of 523? It's the ones digit, the 3, plus the digit sum of 52. Hey, what's the digit sum of 52? Well, it's the ones digit, 2, plus the digit sum of 5. What's the digit sum of 5? 5. And then it peels back through the memory, and it adds them as it goes, like as it finds the information required. So I know that you know the name for this in algebra. It's called a recursive function. This is the base case, and this is the recursive case. So this is like saying, hey, if you don't know, like if you're not the most basic possible steps right now, here's how to chop it down to something simpler. So, hey, what's the digit sum of 1, 2, 3, 4? It's 4 plus the digit sum of 123. What's the digit sum of 123? I don't know, it's 3 plus the digit sum of 12. What's the digit sum of 12? No clue, it's 2 plus the digit sum of 1. What's the digit sum of 1? It's 1. So it's like, oh, you're 1 plus 2 plus 3 plus 4. I like this a whole lot. In fact, I'm going to delete this, and I'm going to delete these guys, because I'm just going to take in a number, and I'm going to store it. You know, I'm going to say something like, store this, bro. And I'm going to call that what I call it in the first place. Sum this. Sum this of ask. And I should probably capitalize the T, because I feel like they should match. And do it correctly this time. There we go. And last but not least, I'm going to do the smart thing. I'm going to print. You know, print store this, bro. Please work, please work, please work. I'm going to say it out loud. Hey, what's 512's number sum? We're expecting 8. All right. So that worked really well. And in fact, if you really want to print the process, I mean, you can like trace it by putting print statements inside of it. You can like hit enter right here and put a print num inside of it, or hit enter here, put a print in there too. That's pretty cool. But you don't have to, just to make sure it works for a bigger number, like 5432 is what, 14? Sweet. And just for laughs, you know, what's the digit sum of negative 17? It's negative 17 because I goofed up here, you know, making a dangerous assumption. So what are you going to do, brother? That's it on functions. I'm probably going to give you a worksheet on it at some point, or we're going to talk about it in class briefly, but I'm not going to spend a whole lot of time on it. I expect you to know this and see how it applies, and we're going to practice it later on when it comes to AP test time. Other than that, I hope you're staying warm and happy and healthy. Harbinger out!